Okay, class 11. Today's topic that we are going to discuss is called principle of homogeneity. Now, as you can see, this word homogeneity over here, it comes from the word homogeneous, and homogeneous means of the same kind or similar kind. So, to put it in simple words, principle of homogeneity tells us that we can only add or subtract things of the same kind, okay, or similar quantities. This is something that you already know actually. Okay, like for example, let me give you an example. If I tell you to add 2 apples and 3 mangoes, how many mangoes do you get? Okay, or for that matter, how many apples do you get? Okay, so when we add 2 apples and 3 mangoes, we're still left with 3 mangoes and 2 apples. We don't get 5 mangoes or 5 apples for that matter. Why? Because we cannot add different things. Okay, we can only add similar things. If I had 2 apples plus 3 apples, then of course we would get 5 apples. Or for that matter, if we had 2 mangoes plus 3 mangoes, then we would get 5 mangoes. Okay, so but we cannot of course add apples and mangoes together. Okay, because they are completely different things. Okay, also in your algebra, also in your mathematics, if we had something like x plus 2x, then you'd get a 3x. Okay, but we would not, these are like terms, therefore they are same kind of things, therefore we added. Okay, but we cannot of course add x to x squared. Okay, we don't get a 3x squared or 3x for that matter in this case. Why? Because they are dissimilar quantities, dissimilar things. All right, so this is something, that is why I told you this is something that you already know, principle of homogeneity. You're already familiar with this. Okay, so it tells us that we can only add or subtract similar quantities, that is quantities of the same kind. Now to speak in terms of physics, that is, we can only add or subtract quantities having same dimensions. All right. Now, a more technical statement for this principle of homogeneity would be the dimensions of all the terms written on both sides of a correct equation should be the same. Okay, of a correct physical equation, it should actually be physical equation, meaning an equation dealing with physical quantities. All right, like for example, see, the dimensions of all the terms written on both sides of a correct physical equation should be the same. Say for example, I take an equation something like S is ut plus half of at squared. This is one of the equations of motion. I hope you're familiar with this. So in here, S is the displacement, of course, U is the initial velocity, T is the time, E is the acceleration, T is the time. Okay, so this is an equation. So what this statement is telling us is the dimensions of all the physical quantities involved in here, in this physical equation, of course, the dimension on the left hand side should be equal to the dimension on the right hand side. That is, the dimension on the left hand side and the dimensions all on the right hand side should be the same. Let's check this. S is displacement, so the dimension for S is m. Okay, or m L to the power 0, T to the power 0. This is the dimension on the left hand side. Now let us look at this term, u into t. So we are adding these two terms, so therefore ut should also be, since we have displacement on the left hand side, ut should also be displacement. Half doesn't have a dimension, so at squared should also be displacement. So u is velocity. Okay, u is velocity. Velocity multiplied by time gives us displacement. DISP means displacement, okay, because velocity is displacement upon time. So velocity into time gives us displacement. Likewise, acceleration into time squared is again displacement. You can check this yourself. Okay, acceleration into time squared is also displacement. All right, so therefore ut is also displacement, at squared is also displacement. So therefore we have displacement on the left hand side, mlt to the power 0 on the left hand side, we have mlt to the power 0 on the right hand side also. We are adding quantities having the same dimension on the right hand side also. So that is exactly what this statement is saying. The dimensions of all the terms written on both sides of a correct physical equation should be the same. So this would be a more, a technical statement for principle of homogeneity. Okay, now to understand it in simple words, this is the statement. We can only add things having, we can only add similar things. All right, now let us look at this example. Okay, this kind of a question you might get in the exam. Okay, so it says if force F is AT plus BT squared, where T is time, T over here is time, and F of course is force, as the question says, find the dimensions of A and B. We need to find the dimension of A and B. So how do we start? We look at the left hand side. Left hand side, the question tells us, it's given to us that F is force and T is time. Now since on the right hand side we are adding AT and BT squared, so therefore since the left hand side is force, you have to understand AT has to be force and BT squared also has to be force. AT is force and BT squared also is force, since the left hand side is force, because we can only, when we add two forces, we get another force. So the dimension of force, like we've seen in the last class also, dimension of force is this much. mLT to the power minus 2 is the dimension of force. So dimension of AT should also be this same thing. So therefore I've written dimension of AT, which can be written as A into capital T, A capital T. We don't know the dimension of A. The dimension of small t, time, is capital T. So therefore mLT to the power minus 2, this has to be the dimension of AT. So therefore from here A is mLT to the power minus 2 divided by capital T, which is this. So mLT to the power minus 3 is the dimension of A. Likewise, you'll find the dimension of BT squared. Okay, so let me do the initial thing. I will write dimension of BT squared is BT squared. This has to be equal to the dimension of force. So from here you'll find the dimension of B. Okay, so this is all for this video, class 11, and this is all that has to do with something called principle of homogeneity. Okay, you might get this kind of a question. All right, so practice this. Once you get hold of your physics book, you can check this kind of a problem in your physics book also.